Hello everyone! In today's video we are going to talk about ROC21 calibration verification and hardware calibration. These options are used for checking the state of the output and input channels of the controller. As a result of these actions, you will get a report with detailed information about your device state and its measurement precision. Let's start with calibration verification. This option is used for the comparison of measurement values delivered by a device under test with standard known values. To use this feature, you need to have a ROC21 controller, Agilent or Keysight multimeter or the equivalent, 4 BNC T connectors and 8 BNC cables. Now let's open our TestUp software and go to controller calibration test. Here we need to select verification. The first window we see is an informational one. Here we see the list of all measurement steps. After that we click next and we need to specify our equipment. We can enter the measurement values from our multimeter manually or make the automatization by installing the drivers for the multimeter and selecting the corresponding option. I have a USB multimeter, so I disable the manual mode and select USB as interface. Here I can see my multimeter model. These buttons in the bottom are used for setting the accuracy and measurement ranges. After we've entered our configuration, we press Next. Here we see a connection scheme. We connect the inputs and an output as shown here in the picture and press Start. At this moment, our device will generate 1 volt RMS at 1 kHz frequency, and we will measure it with 5% accuracy. After the measurements are done, we see a green check image. It shows that everything is okay. After that, our application asks us to change the output and repeat the measurements. Here we see that our second output is also working. Our next step is to check the voltage on the channels. We recreate the connection like shown in the picture and press Start. As we have a multimeter in automatic mode, all the measurements will be taken as a continuous series. The uncertainty will be measured at a range of amplitudes. You can see them in the screen now. The maximum of the measured uncertainties will be taken as the final value. These measurements will take some time, so I will speed up the video. You can see that each measurement is taken 10 times and averaged. All the values are automatically placed into the table. After the amplitudes, we need to measure the uncertainty in the frequency range. As in the previous steps, we recreate the connection scheme and press Start. We will generate a 1 volt RMS signal with frequencies from 0.1 Hz up to 35 kHz. All the measurements will be automatically placed into the table. This step will take more time than the previous one. All the calibration process takes about 35 minutes. In the end, we will see a report creation settings. So we check the settings and create a report with all taken measurements. Now we can continue with the second option in this software module, controller hardware calibration. Hardware calibration is a procedure of tuning the embedded coefficients used in the measurement process. The goal of this procedure is to improve measurement characteristics of the device. As a rule, the calibration is performed at the factory manufacturer before the device is shipped to the user. Usually, the device don't need to be recalibrated as long as the user performs regular verification. The equipment is similar to the previous setup, except you need 4 BNC 50 ohm terminator stubs, and we have an ability to use special RULA RB commutator which can switch the channels automatically. Now it is only used in RULA calibration lab, but maybe in future it can be requested by our customers. So here our first step is the same with the previous calibration. We enter our equipment. We will make all the measurements automatically and we don't have a commutator. Let's press next button. Our first step is to perform outputs calibration. We connect the output of the controller with the multimeter and press OK. Here we'll find the DC and AC shift and compensate it with the coefficients inside the controller. These measurements will be taken for both channels. Then we calibrate the inputs using BNC terminator stubs. We will make measurements for all 4 channels. After this step is done, we go to our final step, input calibration. We connect all the devices as shown in the picture and press start. This step is also done for all the outputs. After all these steps are done, our device is recalibrated and its accuracy will increase. This way you can verify and calibrate your vibration controller. If you have any questions, you can write them in the comment or write us an email. Our support team will answer as soon as possible. I hope you enjoyed the video. Subscribe to our channel and press the like button. It will help us to make more content for the channel. Thank you for watching. Goodbye.